Hello, my name is Walter Unglaub, and this is how to identify protons and electrons. Well, first we want to understand the differences between protons and electrons. Once we understand the differences as well as their properties, then we can identify these different types of particles. So, if we have an electron orbiting around a nucleus, here the nucleus is comprised of neutrons and protons, and this would be an atom, an atomic structure. And an electron, denoted by the letter E, sometimes with this little negative sign as a superscript, is a fundamental particle, or a lepton, and it has a mass of approximately 0.511 mega electron volts per speed of light squared, where I'm using a unit of energy here because this represents the rest mass energy via Einstein's famous equation E equals mc squared, whereas a proton, P, sometimes will have a little plus sign to indicate that it is positively charged as opposed to the electron, which is negatively charged. And the proton has a much larger mass, which is approximately equal to 938.272 mega electron volts per speed of light squared. So we see already that there's a huge difference in mass between these particles. The proton is approximately 1,836 times heavier than the electron. And the proton resides in the nucleus of an atom, and the electron will orbit the nucleus via one of the orbitals, and this depends on the energy level as well for the atom. So the other key differences to note is that while both are fermions, meaning they have half-integer spin, the electron is a fundamental particle. Okay, so that's what's known as a lepton. The other type of fundamental particle, besides mediating particles for the primary forces that determine the physics, are quarks. And a proton is actually a composite particle, meaning that it's made up of smaller constituent particles. And the proton in particular is made up of 3 quarks, meaning it's a baryon, and 2 of these quarks are known as the up quarks, and the third one is a down quark. So these quarks are fundamental particles like the electron, but since the proton is comprised of these various particles, it is actually a composite particle, not a fundamental one. Finally, they both have the same magnitude of charge, but different sign, because there's a symmetry here. And the value of the charge, the amount of charge measured in units of coulombs, is 1.602 times 10 to the negative 19 coulombs. So this is the approximate amount of charge that a single electron or a single proton will have. Thus, if an atom has the same number of protons as electrons, then it will be electrically neutral because the various negative charges will counteract the various positive charges, and you'll have a net electrical charge of 0 for a neutral atom. My name is Walter Unglaub, and this is how to identify protons and electrons.